Welcome to Stir Trek. My name is Krobe. We're here to talk about two of my favorite topics. We have open source software and then risk management. Just to kind of get a general feel for the room, I'm going to step, well, I guess I can't step too far, but just a show of hands. Is anyone here software developer, works in open source? Got a couple of hands. Anyone here a person that deals with cybersecurity risk management? Okay, a couple of hands. All right. What are the rest do you do? Why'd you pick my talk? All right, so we're going to talk about the lazy guide to open source risk assessment. A general agenda for ourselves. We're going to talk about who the hell this Krobe guy is. We're going to just cover briefly some fundamentals of risk management. We'll then talk about what our problem statement is why this matters, and then we're going to talk about what you're all doing wrong. My name's Krobe. I do security stuff on the internet. It's wonderful. My formal job is I'm the Director of Security Communications with the Intel Corporation. I am also the chairperson of the Open Source Security Foundation's Technical Advisory Council and a governing board member, and I run a bunch of working groups there. So I spend my time worrying about the internet, both for my company as well as the open source ecosystem. I'm going to do my best not to curse, but I might have a couple curses slip in here or there. I'm as old as dirt. And I enjoy doing this type of thing, talking to folks, getting engaged with the community. The one hat that I wear that I'm representing here is the Open Source Security Foundation. This is a cross-industry foundation of high-tech companies like Intel, Microsoft, Google, AWS, and also security researchers. We have academics, we have community members, so we have both like upstream maintainers and just general open source folks, and then we just have interested people. So I am the sponsor for the end user working group within the Open Source Foundation, and that assembles large and small enterprises. It's chaired by a gentleman that does cybersecurity for Citigroup. We have people from manufacturing, insurance, banking, just all kinds of different people that show up because they're users of open source and they're trying to understand how to navigate the waters, how best to manage their risk. But the job of the foundation is to try to help open source software and increase the security posture for the whole public good. We do a bunch of different crap. This is not really relevant. If you're interested, go to openssf.org. You can learn about our 10 working groups, half a dozen committees, and all the other stuff we get to do. This presentation is a follow-on for an earlier presentation I did a few years ago. It was called Talking About Risk for Fun and Profit with my boy Cyberface. If you're curious, both that presentation, the presentation I'm doing today, and every other presentation I've done is available on my GitHub. I am at SecurityKrobe, if you're curious, on GitHub. So let's talk about risk management. Risk management's purpose is to provide an effective and efficient strategy for businesses to make decisions and understand, how they can best deliver business valuable outcomes, and it's a primary tool that's used. The primary tool for managing risk is something called a risk assessment, and you need to understand a lot of lay people think that risk is bad, and not all risk is bad, and risk-taking is an intrinsic part of being a business. Steve Jobs made some risky choices when they decided to release the iPhone all those years ago. And I guess that risk kind of worked out for Apple, didn't it? So some specific definitions, and we're not going to be a super kind of quantitative risk assessment session here, but some things to understand. A risk is a possibility of damage or harm. It's a possible problem. And normally you describe that in terms of a threat and a vulnerability. And you also, you can document it as, risk times, threat times vulnerability. And then, a threat is a potential cause of an incident that may result in harm to a system or an organization. And then that vulnerability is a weakness in software, hardware, or some kind of a service that could potentially be exploited and has security implications. You will also sometimes you'll generally see risk expressed as likelihood or probability multiplied by impact. There are kind of 5 main goals when you're trying to perform risk management. First off is you want to identify the problems. What could possibly go wrong? Once you've found those potential things that could go wrong, you want to write them down. Hey, here's my risk register. Here's the list of things that potentially could break or that could cause interruption of service to my business, my customers, my supply chain. Once you've got those risks documented, you'll sit down and start to assess them. And you'll use a risk management framework. You'll have some kind of methodology that will help you understand the probability or likelihood and then the impact or cost of those potential problems. Then you sit down as the security analyst, you make some recommendations. You say, dear business, these are the problems you could have. Here's our suggestions on how to avoid or manage those to an acceptable level. And then, as part of a security program, after all that's done, you monitor. You keep an eye on it, you periodically follow up, and you track to make sure, did that risk go away? Did it become greater? Are there additional things we need to do to avoid it in the future? So, this is one of my interactive parts with the audience. Little pop quiz. By a show of hands or yelling out, how many people here are using open source software today? Let's see. It looks like just about everybody. Oh, you're all so very smart. I love you all. Yes, if you own a smartphone or you use a little thing called the internet or the cloud, you are using open source software every day. How many people here contribute to open source software? I do. Couple? And I'm not a developer, but I still find ways to contribute to the community. And that's something we'll touch on a lot of places throughout this presentation. Code is very important. Helping write, review, patch code, maintain code is great, but there's other ways that people can give back because they want to help support the communities of the software that they use. I want you to think about, this isn't really something you could probably quantitatively tell me, but think about how much money have your company saved by using open source software. Because when you use open source software, you are taking somebody else's work, presenting it as your own, and generally making money from that without supporting that initial developer. My friends at CISA, I was at a conference, and they estimated that the global economy has received between $6 to $8 trillion worth of value by using open source software. So they've had that cost avoidance of not having to invest in developers and infrastructure just by reusing somebody else's software. It's a lot of zeros. So here's our problem statement. And I can't do that. I'll look at it here. Studies cite anywhere between 90 and 98% of all commercial software uses open source. So it depends on which of my friends I talk to. Do I talk to Sonatype or Synopsys? And they always, when they're in the same room, get in a fight about the number. But it's a statistically very large number of the software that you use has open source components. Another interesting number is that over the last few years, depending on what study you look at, supply chain attacks have risen between 450%. I conservatively say 600% here. My friend Brian Fox at Sonotype says it's over 750%. So supply chain attacks have exponentially increased over the last handful of years. And in general, most consumers, downstream companies, even large enterprises, potentially like an Intel or a Microsoft, they don't always understand how upstream works. 742, Brian. This is an awesome timeline, starting with the dawn of time, going into the future when we have flying cars. This is a brief history of supply chain attacks. Most people today, currently working today, will point back to 2010, where there was a small retailer called Target, and they had a breach in their data center through one of their suppliers. While this wasn't necessarily like a supply chain attack, well, it wasn't a cyber supply chain attack. Basically, the bad actor was able to manipulate getting into their network and into their payment card system through a back door opened up through an HVAC supplier. Which was bad. But that's where most of us recognized, hey, supply chain's a thing. We probably should be worried. We should start thinking about it. Things were generally quiet until around 2017, where there was two Eastern European companies got into a disagreement, and one of them decided to send malware to infiltrate the banking and tax system of the Ukraine, and there was some malware called NotPetya, and that was targeted towards a specific geography, citizens of the Ukraine, and unfortunately that escaped and made its way around the globe. It substantially shut down the UK health system for a period of time. It shut down a lot of state and local governments around the world, and that's really when the cyber kind of kicked in and said, hey, we should start doing something about this. And then, ever since then, this is some of the logos of software you may enjoy and use today. NPM, Python, Ruby gems. You'll see SolarWinds. A couple of years ago, a bunch of us in technology had our Christmas holidays ruined by a problem called Log4Shell. And more recently, we had an awesome fella, Jai Tan, who decided to manipulate a package called XZUtils that could have had some really global implications. So again, this is a lot of people are very interested in infiltrating open source software for a lot of the data I've already mentioned to this point. Conversely, there is a system called the CVE program. It used to stand for Common Vulnerabilities and Exposures. They changed the meaning a couple years ago, and now CVE stands for CVE. I don't know, they're super creative, but it used to be Common Vulnerabilities and Exposures. This is a unique identifier for vulnerabilities. And you look back at 2016, there were about just under 6,500 vulnerabilities were reported through the CVE program. Flash forward to last year, we have just under 25,000 vulnerabilities reported. A couple reasons for this. First off, there's more software. There's more people interested in analyzing and looking at software. There's more security researchers. And people are finally becoming more open and transparent. It used to be taboo for some organizations. They did not want to report vulnerabilities openly. Jerks. But thankfully, we've become much more open and transparent about this throughout the whole global ecosystem, and we're having more people participating in the process. So it isn't that there are more problems now than there were back then. It's just back then there weren't that many people looking. There wasn't as much software. So now let's get into the fun part. Let's talk about what you're doing wrong. There's typically two types of people that use open source software. First off, you're going to be hopefully a participant, but normally you're going to be a consumer. So somebody upstream writes, composes, puts it into a build system, a test system, and then publishes it, and then somebody steps in and takes those components. So for example, if you work at a large bank and you're developing the online banking platform, you'll probably grab upstream software directly. Most everyone else in enterprises will have some type of middle person, a supplier that will stand in, an IBM, a Red Hat Enterprise Linux. You'll have some person that acts as that median, and they're doing additional development and testing and packaging and compiling and building and publishing. So there'll be somebody else, an intermediary in between. So your first thing you're not doing is you never checked who wrote your software. I have a slide here in a second where I'll tell you where this could be an issue for you, but you don't know if there's one person writing your software, 100 people writing your software. You don't understand if you have a vendor that's giving you software. You don't understand what they did to that original software, how they changed and augmented it as they provided it to you. And there is a common concern, generally within public sector, governments, that they care about who and where that software, who wrote the software and where it was written. Now, I'll say, as a representative of the open source, we generally don't care. It's a principle. The code stands on its own merit. So if you write good software, if you're a good community member, that's all we care about. We don't care if you're Fred or Sally or Jitesh or Suma, and we don't care where you sit. But there is a certain element, certain verticals within the world do care. So just be aware. But generally, most people don't know who wrote their stuff. So the risk here, to summarize, is third-party software your company uses has unknown or unverified components that are of unknown pedigree, provenance, quality, and origin that you use within your operations and productions environment. So the first step that you can do to manage this risk, to try to help either, you're probably not going to terminate that risk. You're not going to stop using open source software, but you're going to try to help manage it better, mitigate risks. First thing you're going to do is I should tell you that you should only acquire software from known, vetted, and trusted sources. And if anyone here is a developer and you're copying software off of Pastebin, please stop. Pastebin is the most bug-ridden cesspool of software on the planet. There are much better ways if you're going to open source software instead of copying from Pastebin. One thing you can do as a commercial enterprise is you can require your suppliers to give you something called a software bill of materials. It's an artifact that lists off, these are all the components included in this piece of software that I have provided you. Ideally, it talks about kind of the manufacturing, like how that software was composed, like what the build infrastructure was, if there was GitHub actions, what those were, how the code was signed. So there's more information, but at its most elemental level, SBOM tells you all of the software components inside of a software product. So ask for that. Tell your vendors, I require this. You can use tools. The OpenSSF has a tool called Scorecard that helps provide some of this information. It will tell you, who wrote this, how big the community of developers are around this piece of software, and there's a bunch of other security attributes that Scorecard will tell you about. And as I mentioned, everything in this presentation is hyperlinked. The presentation's already in GitHub, and I'll work with the StirTrek staff to get it into the Discord, so you can take a look at this and actually go to some of the examples or citations I'm providing. Some other tools that you can use. One of my working groups, we wrote something called the Concise Guide to Evaluating Open Source Software. This is a checklist. It's a page-and-a-half document, and there's about 18, 20 things you can do as an open source consumer, things you can check or things you should do to that software as you're ingesting that into your environments. And then there's also something, my friends over at Microsoft wrote this and donated to the community, is I'm going to get this wrong, it's the Secure Supply Chain Consumption Framework, S2C2F. This is a framework for downstream consumers, and it provides maturity levels of, hey, if you want training wheels, here's 3 things you could do. If you want the Maserati, here's 50 things you can do as you're ingesting open source software. So I would strongly recommend kind of looking at these resources and integrating them into your practices. Since I mentioned it, anytime you say SBOM 3 times, my dear friend Alan Friedman shows up, and now the jerk is a cartoon. SBOM's a big thing. I've been involved with SBOMs for almost a decade. Since the second NTIA meeting. It's important, and it's a challenging space, so if you're a software producer and you're not doing SBOMs, stop it. Make SBOMs now. If you're a consumer, talk to your suppliers about getting you machine-readable software bills of materials so that you can start your risk assessment and understand what kind of controls you need to put in place to manage that. The next thing you didn't do is you didn't check what the developer wrote is actually what you installed. There's a lot of strange things that can happen, and looking at open source, it's predominantly about source code, and that's our core tenet. Everything we do is publicly viewable. Anyone can come in and look at it, perform their own testing. If they see problems, they can suggest fixes. They can fork it and make their own version of that software. That's elemental to what we do. This software is generally compiled, tested, composed, and built leveraging public infrastructure. But all of that piece, which generally isn't talked about a lot, is just as important as what the software does. And that's how a lot of these supply chain attacks are being executed, is attacking the build pipeline. And when you're thinking about this, you're trying to understand kind of what got installed, you're going to bump into 2 of the hardest problems in computer science, naming a thing and versioning a thing. If you want to get into a real nerd fight or waste a lot of time on the internet, read debates about software naming and software versioning. You'll waste 5 weeks. So thinking about this build infrastructure, what's the worst that could go wrong? Quite a lot. So thinking about on the consumption end, my friend Esteban, the software enjoyer, he got a package off the internet or from a vendor, installed it. Well, he unfortunately is susceptible to a couple of different attacks. He could have vulnerabilities on his system that allow an attacker to allow them entry into his network. There could just be a software vulnerability that he installs a software and now he's susceptible to an attack. Thinking about like the publication and distribution infrastructure, in here a malicious package could be inserted into the supply chain through something like typo squatting, DNS redirect. There's a lot of scary things that can happen here on the publication distribution side. Thinking about the build, compose, and compile side, you could have things like name confusion. You could tamper with an exposed build system. I mentioned these developers develop generally on publicly accessible infrastructure, so it's accessible to them. It's also accessible to the bad guys. Thinking about the software, the development process, as the developer is testing and picking dependencies, there, you could potentially have someone join the project and contribute as a maintainer, a bad actor sneak in. You could have the maintainers, either their development environment or their testing and build environment get compromised. You could have somebody subvert a legitimate package, and then my personal scariest, and this is what just happened recently with the XZ utils, the bad guy can become the maintainer, take over a project, a formerly legitimate project, and start publishing either malware or software that is altered to allow them to perform additional actions after you've installed it. So the risk here we're talking about is third-party software at your company that you use within operations or production has unknown or unverified build, test, and publication information. You don't know how this was built. Two main controls or processes or actions you can take is you can understand how that software is compiled, assembled, tested, and published. There is a tool, a framework that our foundation offers called SALSA, which is right here, SALSA. And that is I'll get this one wrong too, Supply Chain Levels of Software Artifacts. We love our acronyms in open source, so I always call it SALSA. And I didn't know for a year and a half what the hell the acronym stood for. But so you could go out and understand how that was built, composed, and piled. There's ways that you can get attestations or certifications about that process. And then you should only use signed software artifacts, whether that's a signed SBOM, it's signed packages. You should not be using rando things on the internet that Frank wrote and you don't know who the heck Frank is. Some other things you can do, there's a tool called SigStore. This is a public infrastructure for code signing and developer identity verification. So like things like Kubernetes project and a lot of big ecosystems are starting to leverage signing. Our developers here probably understand that code signing has been a very long-standing challenge within software development. And we used to use PKI infrastructure, and there's been ways that that's been compromised. But SigStore is a new, modern way that kind of integrates into developers' workflows. So it's, I won't say frictionless, but it's pretty close. It's a way to sign, to say, on this day, on May 3rd, 2024, Krobe signed this artifact. And then it's up to you as the consumer to decide, do you trust this shifty Krobe guy, or do you want someone else to do an additional check? You want to do a check yourself. You always, as you are incorporating software into your enterprises, you need to do scanning. And that could be things, SAST, DAST, source code analysis, fuzzing. You absolutely should do dependency checking. I'll talk about that in a slide or two. And you should look for known vulnerabilities and understand, are there fixes? So some other things you can look at, we have a C and C++ compiler hardening guide. So if you're a software producer and you write software in C or C++, we have some guidance on how you can do that better when you're at the compilation stage. We also have source code management best practices guide. So if you have a source code management system, like a Git system, there's guidance on how to configure that to make it as secure as possible. We also worked with CISA on some principles for source code management principles. So as you are looking at picking software off the internet through things like Maven or crates, this is guidance on how those repositories should be configured. So you can look at that and see, this is a standard of quality that you should look for. Is the place you're downloading the software following that? And then you can have a conversation with that repository. And then we have that concise guide to evaluating open source software, which is pretty cool. Another thing you're not doing is you're not checking how the developer secured the software or if they did anything with security at all. I have another presentation. I was at the Open Source Software Summit about 2 weeks ago, and I had a room full of developers, and I was kind of giving them coaching on steps they can take to integrate security into their process. But, developers, if they're a professionally trained software engineer, their job is to write and engineer software. It's not to be a security jerk like me. So they don't understand. They either haven't had training, haven't had exposure, don't understand the concepts. And this is very prevalent. And I'm going to talk about my pal Diana, the weekend warrior. This is a persona that is incredibly common with upstream software. This is the software you're using. The overwhelming majority of the software you use is written by a single maintainer. One person writes that. Writes, maintains, upkeeps, whatever, the whole shebang. And most enterprises don't understand that. And these weekend warriors, I would encourage you to go look at this persona. Most of their time is spent keeping up with dependencies and fighting their tool chain. Some upgrade happened, and now their build won't work. So most of the developer's time is spent with operational fiddly things, not about adding features or functions or addressing security updates. So looking at the scope of open source software, there is something on the order of tens of millions of open source packages available on the internet. Of that tens of millions, an order of magnitude, dozens of the tens of millions of software packages have a dedicated security team and have sometimes up to 100 maintainers that participate in the curation and upkeep of that software. So let that sink in. The next grouping, it's on the order of magnitude of hundreds of projects on the internet have between 2 and 100 developers on the team. Then there is at least 16 million to 40, 50 million. It depends on, again, what statistic you're looking at. These projects have one person that writes it. They may or may not make commitments to maintain it. They may or may not have security training. And I would encourage you to go look at the Anchor blog where Josh Bressers actually sat down and did some analysis of this. And it's all publicly available information. And so if you are a large enterprise that is leveraging open source heavily, you need to understand that this is a potential risk for you. That there's one person, they may get sick of doing it and quit and stop maintaining it, and you have a dead project. Or you have what happened with XZ Utilities, where you have a malicious actor kind of step in and take over a project because of burnout. So your risk here is your company uses software that was created and maintained that has unknown software development lifecycle practices. So for software that you care about, you should understand what the most critical software is that your organizations use. You should find out what those components, projects, practices are. Find out how they develop, what tools they use, what kind of support they offer. There are some ways you can also help. There's the best practices badge you can look at. Some people will go through a certification progress, saying my project's certified okay. Others, we have a guide for developers that shows them techniques and tools and practices to develop more secure software. And then we also have that S2C2F framework I mentioned. As a consumer, you can go look at, has a maturity scale, so you don't have to go jump into NASA. You can start off with a lemonade stand of type controls you want to do. And this one should be fun. So as a consumer of open source software, you probably don't know what software you have installed or what that software installed for you as it was being implemented. Depending on the language or ecosystem, and this varies drastically, you're typically going to have a minimum of one dependency. You install a package, it's probably going to need at least one more. And some things require hundreds to thousands of dependencies. And these are libraries, files, configuration things. There's a bunch of stuff, cruft, that gets installed along with your WebSphere server, for example. And another fun fact is sometimes you might be able to understand what the dependencies are. So I installed the Linux kernel, and I understand what the Linux kernel needed for dependencies. But those dependencies will also have dependencies, which also have dependencies, which also have dependencies. And it's turtles all the way down. So let me show you. This is Composer. Yeah, this is Composer, and this is the dependency tree map of Composer. So here's I think Composer, I think it's YAML, and it installs on the order of, I don't know, a couple dozen dependencies. And a couple of them have dependencies. Pretty neat. This is fairly simple. Let's look at Gatsby. So you install Gatsby way up here. All this other crap gets installed along when you install Gatsby. And just to do a zoom in, this is one piece. This is this. There's a little box somewhere on here, up here. That's just one level of the dependencies that get installed. Is that concerning to anybody? No? Oh, yes. Yay! Thank you. So, the third-party software you're using has unknown or unverified, either transitive or intransitive dependencies. Things you can do immediately to reduce this risk. As you're installing software, understand what needs to be there and what can be removed. If you reduce the attack surface in your environment, if you're a developer, don't add in a bunch of extra dependencies. Very, very aggressive in how you're managing what gets installed. If you're a company, as things get installed, you need to be very aggressive in managing. What can we turn off? What isn't used? So if you reduce that attack surface, you're reducing the amount of work you have in the future when you're in vulnerability management. Oh, dear. We have a tool called Guac that does that dependency tree analysis. Free open source tool. Every tool I talk about is 100% free, publicly available. There are commercial things that do this. I don't care about those. You might, I don't. I'm going to only talk about the free stuff. We have the concise guide, and we also have S2C2F. Another thing you didn't do is you never checked that the developer made any kind of commitment to fix problems. Has anyone read an open source license? A couple? I bet you didn't know. This is the Apache license. Every open source license essentially says the same thing. This software is provided as is, no warranty. You should have no expectation of support. The developer has no liability to you. And this is, the language is a little different depending on the license, if it's MIT or Creative Commons, but that is the core of almost all open source licenses. So you're using software that out of the gate, the developer says, I don't support this. Does that sound good? So things you can do. You want to make sure that the software you consume has a documented support lifecycle. Good projects, and the majority of projects, will give you a support policy saying we support the latest version and N-1. We'll support the main and one version back. And we will provide these types of updates. We'll do these security things based off severity. So research the software that's critical to you, what you can expect for support. There are ways you can mitigate this. You can pay for commercial open source software support. That's like the Red Hat model. They make their money off of support. The software is free. You pay for the support and service and the ability to influence to try to help to get features put in. So that's a way you can help mitigate that. You need to check and make sure that the upstream has a security MD file or some type of security.txt, security policy, has some type of file that says, we will do blah when there's a security vulnerability reported. And there are signals, whether it's scorecard, best practices badge, all-star, security insights. There are ways that you can see how those upstream projects handle security. The upstream, another problem you do, you don't understand. A lot of people don't understand you're not getting a warranty. You also aren't monitoring when they fix stuff, when they publish updates. Many of you are relying on something called the National Vulnerability Database, which is a giant database of vulnerabilities. Fun fact, if you didn't know, the NVD's purpose is to monitor software and vulnerabilities that the United States government cares about, that is deployed in US government systems. Does that sound like all software? It's not. And they make no commitment to that. And so there is a large piece of vulnerabilities in the ecosystem that aren't represented in the NVD. So you need to make sure that the upstream projects that you really care about, are they fixing it? When they fix it, how do I know? Where does that signal show up? Oh, yeah. I get to have a lot of meetings with Brian Fox. He's a hell of a guy. He's the CTO and founder of Sonotype. They run Maven Central, which is a large package repository. He also just is a huge open source advocate. Has anyone heard of Log4Shell? Again, that was that little problem that happened around Christmas a couple years ago. This was a screen capture I made a couple days ago. As of a couple days ago, 34% of all versions of Log4j were malicious that were downloaded. So 1/3 of all software of Log4Shell that people were installing is vulnerable. It was fixed back in December of 2021. So, and this is not a unique problem. And Brian has some figures, but he estimates that about 70% of all software, people are downloading vulnerable versions when there already is a fixed version available. You're downloading the wrong stuff. You're pinned on an old version. You weren't aware when an update or commit happened. Yeah, so that's a bit of a problem. What you need to do is find out how those critical projects communicate. When they fix it, how are they telling you? We have a database and a schema called the Open Source Vulnerability Schema, OSV. So if you care about open source specifically, this covers, I don't know, maybe 75, 80% of the open source ecosystem. So that's a great place to start, and there's other places you can look at where you can get signals. NVD is fine. They're laggy, and they only care about a subset of software. It may overlap in the Venn diagram of software you care about. That could be good enough. It might not. And there are things like the OSS security list. This is a institution within upstream open source, and this is where most open source projects will communicate, on this day we fixed a thing, there was a vulnerability, here's how to get the patches. Subscribe to that mailing list. Subscribe to other mailing lists, whether it's a blog, it's a project mailing list. If you're in an ISAC or other style group, there's a lot of ways you can get this. And then my foundation is making a new mailing list called Siren, where as we are aware where there's open source software that is being actively exploited, we're going to publish TTPs and IOCs publicly so people can understand these things are being exploited. Here's how to look at and find it. So in conclusion, and I have about 12 minutes or so for questions if anybody cares, or you can rush off to the next session, or continue your nap, whatever you like. Open source software it's an amazing public good. It's vibrant. There are some of the greatest people I've met in my career upstream that participate within open source. Using it is not free. You need to invest. It doesn't have to be money, but you need to invest time and resources into how you use it. So I summarized, so if you didn't get anything else, there are 6 things you can do to help manage your risk in using open source software: understanding what open source you're using, reduce your attack surface, combine your asset inventories with SBOMs. If you're not doing asset management internally, you need to. You need to combine that with SBOM. There are other technologies like VEX that allow you to give you quick, fast signals when there is new problems. Always use the latest and greatest software. Don't hang out on an 8-year-old version of some library. That's just, you're going to have a bad day. Monitor your upstream suppliers, and CVSS, which is I helped write, is the Common Vulnerability Scoring System. It is a methodology to describe how a vulnerability works. CVSS does not equal risk. Ignore the number. They'll give you a number, so CVSS 8.2, CVSS 2.8. A number is not risk. Take that information. The most important part of CVSS is the description string that tells you how the vulnerability works. Take that as part of your own risk assessment process and layer on your enterprise controls, layer on what your critical data and systems are, make your own risk determination, and determine your own priority on how quickly things get fixed. So with that, are there any questions? I'll move over to the side here where I can get out of the lights. Does anyone have any questions that I can answer?
There's a question in the Discord.
Nice.
Can you actually read it?
I cannot.
For the overflow here?
Oh, I'll restate it for sure.
I'll bring it here. This is just for the people in the overflow to hear it.
Right. So the question, Bill Senf, who is awesome. Hey, Bill. Hi. Oh, you're here. Nice. So a random internet person, Senf, asks, all of these OpenSSF and OWASP tools we're using, are we looking at them for vulnerabilities? That's an excellent question. The answer is, it depends. Anything within that is part of the open source security foundation, we now have some requirements that as folks enter our project lifecycle, all of our software tools will be required to have a vulnerability disclosure program. They'll be required to do scans, be in scorecard. So that's a maturity thing, and it's a herding cats exercise. Trying to get volunteers to do extra work is challenging. So, but yes, OpenSSF tools, we are in flight. OWASP, I think I can't state for sure. Oh, well, expert in the audience can. So does OWASP scan their stuff?
That's why they moved to GitHub largely. OWASP moved everything wholesale, the website, the whole deal to GitHub, specifically to take advantage of the stack analysis tools.
So expert audience participant says OWASP has moved everything into GitHub to take advantage of all the tools that are there. Dependabot, all the really fun things. And my friend Madison actually owns a lot of that infrastructure at GitHub. So yeah, GitHub is a great, so generally if you're getting software from a big thing like GitHub or GitLab, there are tools available. Turn them on, check them, and then projects that you use, encourage them to turn on those things. Question way in the back.
So some organizations have great security infrastructure, scanning for CVEs and all of that in their software development space.
Mm-hmm.
But then in their model development and analytics space, they're just like, here's your prod project, do whatever you want.
Mm-hmm.
Proxy, right? To download your software. So like, what are the recommendations? And the people who work in those spaces are becoming more and more savvy, right? So they're using more and more tools without having any security training. So like, what are your recommendations in terms of like changing the culture?
Mm-hmm. So the audience member noticed that most traditional enterprises have good SDLC practices with scanners and tools and gates to get into production. Those controls don't always exist in the data modeling, data science, and AI space. Fun fact, software is software. You can apply almost all of these tools to those environments. There may be some adjustment that needed, and you may need to find specific vendor tools, but all of these practices, monitoring your dependencies, scanning, it's just software. Artificial intelligence is just a giant shell script in a database. It's a bit giant flat file. It's not magic. Use the same discipline, the same tools there that you would use, even though on these new technologies. The principles still apply. Question here.
I don't have a specific question, so I just want to hear you comment on it, but because I've been studying the cybersecurity
Cyber.
like IoT hardware, OT security, and that's kind of interesting because that's just a different ball game because you literally often don't have the space in the device for, you can't think of it like you do like say a Java app.
Mm-hmm.
And a lot of that stuff was
I can. So the audience member commented that there's this other space we don't always talk about, Internet of Things, embedded devices. Does anyone have a Tesla that has a computer on it that runs a lot of crap? And there's limitations when you have an embedded device. You don't necessarily have memory. You can't deploy tools directly on that. And there are challenges. But at its core, those organizations that jumped on the gold rush to go sell you a talking teddy bear or a camera that lives inside your refrigerator, they need to follow the same traditional software development practices that other software uses. There may not be a fuzzer, well, it probably is a fuzzer, but there may not be a sort of static code analysis tool for that environment, and it can't live on that chip, but they need to do that as they're doing their modeling, because it all gets modeled inside a computer model before. They need to perform all that. They need to threat model it, understand what the limitations are, and reduce that attack surface. And not a lot of those IT vendors had done that. We've had some very high-profile breaches by nation states on Wi-Fi routers and doorbells and whatnot. So hopefully a lot of these companies are realizing this. But yeah, definitely is a challenge. It's the same principles. You have to modify for what your available memory and storage are, though. Did I answer your question? Kind of, okay. I did my best. But it's not. My company, we make computer chips. We're a small little computer chip company. There's software that lives inside of every computer chip. There are things you need to do before you bake that firmware onto that chip. And it's the same principle for a router or a teddy bear or a car. You need to have that rigor, that engineering discipline before you commit to burning it, and you need to understand what your capabilities are of updating after the fact. Can that device be updated over the air, which is an option for some things? They need to understand kind of what the capabilities are, what the potential threats would be, and make plans to protect your consumers. Thank you. Anything else before I get kicked out? Sir? So the skeptical audience member asked my opinion on how much do I trust something out of the box. If I was going to buy a router or a doorbell or whatever, do I just install it and away I go happily on my way? And my answer is I don't trust a damn thing. I own a tinfoil hat, and I first will do some research. I'll go to that vendor's website, understand what the latest firmware versions are, and I will always install latest firmware before I turn it on to the internet. And even then, like for IoT devices, I jail in their own network on my private network. I don't let have access to my other stuff. So, it's consumer beware. Do your own due diligence, perform your own risk assessment, and understand what your risk appetite is. You might not care that nation states can listen to you from your light bulb. That might not be a problem. You might have a smartwatch, a smart device, and Alexa. They listen to you all the time. Do you accept that or not? And it's kind of a personal judgment. But I always check to see, I apply the latest updates, and I see are there any unpatched vulnerabilities or any problems? How reputable is this vendor? What's their track record of fixing security things? Any other questions? All right. Well, thank you to all the people here that watch me wander around. Thank you to the people in the other theaters. Great experience. If you have any questions, I'll hang around a little bit. Enjoy the rest of Star Trek. And the movie's coming up in just a couple hours. Cheers.